Hey everybody. So last time we were talking about hypothesis testing for means with large samples, aka samples that are 30 or bigger. I wanted to show you an example of what to do if you are testing a hypothesis for a mean, but you are dealing with a small sample. So let's get started. So there's two main differences. We're going to be using t-scores instead of z-scores, and pretty much a slightly different math formula. And that's about it. Let's start with the slightly different math formula. As you can tell, not much different. The only difference is because we are using t-scores instead of z-scores, we're going to be using t equals and then all of that normal business instead of z equals. And that's literally the only slightly difference about this formula. Second, t-scores again, we are going to be using t-scores instead of z-scores because we are dealing with sample sizes less than 30. And the way you're going to do that is you're going to still look up which tail test you're doing at the top part of the t-chart, and you are going to look for the degree of freedom to find your row. Give you a quick example of this. So say, for example, you have a sample size of 7 and a level of significance of 0.05. Let's find the t-score for left tail, a right tail, and a two tail just to kind of get you acclimated with how you would do that. So again, we're going to start by looking up here. Let's start with the left and right tail. It's a one tail test. And we're going to be looking for 0.05 at one tail. So this is the column that we are going to be using. Next, what we're going to do is we're going to use the degree of freedom formula, which is again always one less than the sample size, to find our correct row. So again, our sample size is 7, so our degree of freedom would be 6, because 7 minus 1 is 6. So here we go, 0.05. Down to the 6th row. So there we go, 1.943. Now, if you're doing a left tail test, you would just make that a negative 1.943. If you're doing a right tail test, you just leave it a positive 1.943. Same with the z-scores we were doing before. Now, if we were doing a two tail test, same idea. We're just going to look at the two tails now, find 0.05, which is our level of significance, and then go down again to our 6th row, that's the degree of freedom, so 2.447. And for this one, again, for two tails, you're going to make the left side negative 2.447, and then the right side positive 2.447. So just kind of putting that all together, there's the answers. So the left tail again, negative 1.943, right tail 1.943, and then our two tail t-score for our two tail test if our sample size is 7 and our level of significance is 0.05. All right, and that's mainly the big difference. So let's put it all together for an example problem real quick for you guys. So here's the example problem. A researcher claims that a diet program helps its participants lose more than 15 pounds in 1 month. To test this claim, a second researcher has 12 people use the diet program for a month and records the following results for the participants. So person 1 lost 13 pounds, person 2, 10 pounds, 9 pounds, so on and so forth, right? At a level of significance of 0.01, can you confirm the claim is true? So again, that level of significance, again, is just the probability that your, hypothesis test is wrong. So with a 0.01 or 1% chance of being wrong, that's a pretty, our conclusion will be pretty, for the most part, pretty accurate. So let's put this all together. So step number 1, let's write the claim. So the claim again is that it's more than 15 pounds. So that would be mean is greater than 15. And because greater than is not an equal sign, that claim is going to be the alternative. So it's going to end up looking something like this. So the mean is going to be greater than 15 is the alternative. And then the opposite of that would be less than or equal to. So this would be the correct null and alternative hypothesis for the problem. Our alternative tells us our tail test. So because that is a greater than symbol, our alternative is telling us this is going to be a right tail test. And let us confirm that this is the correct t-score. So again, I'm going to go over here. This is 0.01, one tail, 0.01, and our sample size was 12, so our degree of freedom is going to be 11. So there would be our t-score for the problem, so 2.718, which is what I already have in the notes. So that is how you get that number. The next step would be the math part. So the math part would be, in this case, we're going to actually have to do the math part ourselves a little bit because they're not telling us what the mean is. They're not telling us what the standard deviation is. If the problem already gives you that, then great, you can just do the math part. But if they don't, then you're going to have to use a spreadsheet. So I've already entered those numbers here from the study, and all I would have to do is get the mean of that and then the standard deviation of that. So I'm going to do that real quick. So equals average for the mean, and I'll just select those, and that would be 15.8. So the sample mean is getting us, again, the claim mean's more than 15. That's slightly more than 15. Let's get our standard deviation. Standard deviation dot s, because we're using the sample standard deviation, because this is just a sample. And it's going to be 5.02. So let us continue. So our sample mean again is 15.83. We got that from the spreadsheet. Same with the standard deviation. Got that from the spreadsheet. Sample size is 12. They just stated that for us. And then our math part of the equation again is sample mean. This is same as what we were doing before, minus the claim mean, 15, divided by the standard deviation, and then the square root of n. So I'm going to pause for a second. Try to plug that into a calculator. Make sure you're doing that part of the problem correctly. I'll pause. Done. All right, here we go. So I got 0.57, and let's figure out if this does make our claim true or false. So 0.57, again thinking number line, is going to be left or right of 2.718. And if you guessed left, you are correct. 0.57 is definitely left of 2.718 on a number line. So that puts us in this not shaded section. When you're in this section, that means HO is true, HA is false. So HO, if that is true and HA is false, that must mean, because our claim is HA, that our claim is false. And that would be an example problem for these. So again, very similar to what we were already doing. Only main difference is the math equation has just the t instead of the z, and then obviously you're looking up a t-score instead of z-score at the bottom there of that t-score chart. And that's mainly it. So our attendance task today is just making sure that you're looking up the t-scores correctly. Hopefully that'll be a quick attendance task, and then I got 6 problems of these hypothesis tests for you, and hopefully this is making a lot more sense. If you have any questions, you can always email me or drop into opposite hours, which is every day, Monday through Thursday, 1 to 2 p.m. You guys have a wonderful day. Thanks.